Hello, my name is Russell, and in today's video I'm going to be talking about the different types of radiographic imaging, primarily computed and radiographic imaging. As you may know, radiographic films like this were the only source of obtaining a radiographic image. These films are plastic-based receptors with elements that absorb X-ray photons. These films have advantages and disadvantages. One advantage of using a radiographic film would be that the image would be one of good resolution. But on the other hand, some disadvantages of using these films would be that when developing the film, it may get stuck into the image processor, or an undeveloped film may come in contact with an outside source of light, which would cause us, the technologist, to re-examine the patient and having the patient to absorb more X-ray photons in this process. This is the film processor, where we would place our film into the feed slot here. Then our film would travel down into the system using different types of liquid chemicals and other components to develop an image on the other side. This whole process is how we obtain a radiographic image on film. Moving on, I'm now going to speak about computed radiography, also known as CR. CR uses cassettes very similar to film, but instead of having film inside, it has an imaging plate, also referred to as an IP. Once this cassette obtains an image, we will then process it using the CR processor here. To do this, we place the cassette with this end into our CR processor, like this. Once inserted, the processor will read the image, process it, and we will be able to display it here for evaluation on our monitors. Next, I'm going to talk about digital radiography, also known as DR. This is a direct acquisition system. This system will give us an image sent directly to our monitor. First, an image will be taken. This image will be sent down here into our Bucky. Once the image has been taken, it will be directly sent over to our monitor here. This system needs no film or cassette and can be referred to as a filmless system. In conclusion of this video, today I have discussed radiographic imaging, primarily computed and digital radiography. Also explaining how these systems work, how to obtain a latent image, the components of these systems, and how these systems develop an image. Thank you, and have a great day.
Layers of the photostimulable phosphor imaging plate. The first layer of this plate is the protective layer, which simply insulates the imaging plate from handling trauma. The phosphor layer holds photostimulable phosphor, which is an active component in the plate. The conductor layer grounds the plate to eliminate electrostatic problems and absorb light to increase sharpness. The support layer is simply a base on which to coat the other layers. The light shielding layer prevents light from erasing data on the imaging plate or leaking through the backing layer, decreasing spatial resolution. Barium fluorohalide bromides with europium activators. These 4 circles represent europium, and the 4 red dots represent electrons of the europium. X-ray photons will come in contact with the europium electrons, causing a photoelectric effect. These electrons, having come in contact with the X-ray photons, will emit light. While emitting light, these 4 electrons are pushed from the europium activators and moved in between them into the center of this area called the lattice. The europium now has what is called a hole, having an electron being removed from the europium. These holes of the europium are now filled with the latent image. Computed radiography, also known as CR. First, the CR cassette with a latent image will be loaded into the CR processor. This latent image, which is on an IP plate, will be slow scanned and also fast scanned. Reading the imaging plate involves a focused red laser beam that frees trapped electrons, allowing them to return to a lower energy state. This process is known as photostimulated luminescence, also known as PSL. These electrons in the latent image moving from a high energy state to a lower energy release a blue-purple light photon. These blue-purple light photons will travel to the photomultiplier tube, also known as PMT. The PMT will convert the blue-purple photons into an electrical signal. This electrical signal will then travel to the analog digital converter, also known as the ADC. Now, after being converted from an electronical signal to a digital signal, represented by this binary code of ones and zeros, the signal can now be sent to our computer, then to our monitor, displayed as a radiographic image. indirect acquisition of digital radiography, also known as DR. X-ray photons will come in contact with the first layer of our indirect acquisition system. In this step, X-ray photons will come in contact with cesium iodide. The cesium iodide will convert X-ray photons into light photons. The light photons will then move to the amorphic silicon. The electrical signal produced by the amorphic silicon will then travel down through the thin film transistors, also known as TFTs. The TFT collects electrical charges as an array or matrix of pixel detector elements, also known as DEL. The DEL stores this electrical signal in a sequence of patterns. Once the DEL has organized the electrical signal, it is sent to the ADC, which then converts the signal into a digital signal. Once the signal has been converted to a digital signal, it is sent to your computer and then to your monitor, displaying the signal as a radiographic image. Direct acquisition of digital radiography, also known as DR. X-ray photons will come in contact with the first layer of our direct acquisition system. In this system, X-ray photons will be directly converted into electronical signal by the amorphic selenium. After the amorphic selenium converts the X-ray photons into an electrical signal, it will travel down the thin film transistors. The DEL stores this electrical signal in a sequence of patterns. Next, the ADC converts the signal from the DEL into a digital signal, which is then sent to the computer.
In conclusion of this video, today I have discussed radiographic imaging, primarily computed and digital radiography. Also explaining how these systems work, how to obtain a latent image, the components of these systems, and how these systems develop an image. Thank you and have a great day.